I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I'm your host, Jesse Lawler, excited to bring you the 46th episode, a little bit late on this one, of this podcast dedicated to the betterment of your own brain by any and all means necessary. This is a back to the basics core Smart Drug Smarts episode all about smart drugs. In this episode, we are talking about something I've got a lot of listener requests for over the months, and we've managed to track down the world's leading expert and in fact one of the inventors of this substance. I'm talking about something, the chemical name of which I will not pronounce right now, but which you might know as Noopept, if you want to pronounce it the easy-to-do way, or Noopept, if you want to kind of get that second little O sound in there, which I'm always torn as to whether I should say nootropics or nootropics, because it's actually from the Greek word nous, or something like that, which means mind. Yeah, when you're talking about nootropics, there's some Greek to me stuff involved. Anyway, Noopept is a Piracetam-like chemical, which is not so well known in the West, but quite a bit more so where it was invented in Russia and in Eastern Europe. It's apparently getting more use than it is in the USA and Western Europe, but there's a lot of things that make it worth knowing about, including its neuroprotective benefits and the fact that it has a really, really low toxicity profile. There don't seem to be a lot of bad things one can say about Noopept, but we'll get into all of that in the main interview. If you hang around until the end of the episode, in our ruthless listener retention gimmick, I'm going to tell you about how to take the ultimate nap, insofar as getting maximum mental springiness on the far end of the nap, which is, I guess, what we take naps for to begin with. But before we get into any of that, let's do This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
Okay, so if you want to talk about brain plasticity, the ability of the brain to kind of roll with the punches and rewire itself on an as-needed basis, this one is amazing. Doctors in China recently came across a woman who has no cerebellum in her brain whatsoever. So a 24-year-old woman went into the doctors with complaints of dizziness and nausea. One thing led to another. They did some brain scans and they found out that this woman's entire cerebellum wasn't there. Now, if you can kind of imagine the picture of a brain, there's this little bulb down at the bottom, sort of at the base of the skull in the back. It almost looks like a miniaturized version of the brain kind of shoved on the back of the brain. Anyway, that's the cerebellum, but it's about 10% of the brain's total volume. So it's not like a small little micro minuscule piece of the thing. And it also contains up to 50% of the brain's total neurons. This woman did not have a cerebellum at all. It just wasn't even there. The x-ray scan is really quite amazing. The woman told doctors she had had problems walking steadily for most of her life, and her mother said that she hadn't walked until she was age 7, and that her speech was only intelligible at age 6. So she had some developmental problems, but basically was a fully functional adult missing a giant piece of her brain, says Mario Manto, who researches cerebral disorders at the Free University of Brussels in Belgium. These rare cases are interesting to understand how the brain circuitry works and compensates for missing parts. Doctors suspect the functions normally taken care of by the cerebellum in this woman may have been taken over by the cortex, and that they're doing brain scans now to kind of figure out how exactly her brain has rewired itself to make up for the lack of this usual piece.
Smart Drug Smarts, where we turn information into sound, into bits, into packet data that turns back into bits and sound, and then into neurotransmitters that release funds that release mail-order synthetic chemicals that cross the blood-brain barrier to release augmented performance from your brain.
Okay, so as promised, we're about to go into our main interview with Dr. Rita Ostrovskaya, who is quite literally the foremost scientist in the world on the compound Noopept. We reached out to her and invited her, and she very graciously accepted, but in her initial email, she was a little bit concerned about communicating in spoken English, because English is not her first language, and so on and so forth. So for a while, we communicated, and we were thinking that maybe we would do a text chat interview and then have sort of a stunt voice come on and voice her part of it. But just when I was ready for the text chat a night or two ago, Dr. Ostrovskaya arrived at the agreed upon time and just gave me a phone call and said that she was ready to do the interview as a normal audio interview, and so we did. But because of that, we hadn't had time to kind of get her audio environment set up, and there's definitely some pops and imperfections in the audio conversation, so I apologize about that in advance. There's also a couple of words that I want to give a little bit of a glossary to, just to make sure that nothing gets misunderstood on the basis of Dr. Ostrovskaya's accent. There's a few times when she says what sounds like chemists, and that would be chemists. Similarly, chemical is chemical. And there was once or twice where she was talking about peppers, And then I realized that's paper, like scientific paper. So if you hear her talking about peppers and you're wondering what the relevance of peppers is, that's what's going on. And lastly, there's a few times when years are pronounced ears. So with that as preamble, here comes a really interesting interview with one of the leading minds in nootropic research chemistry, Dr. Rita Ostrovskaya.
Smart Drug Smarts.
I am one of 3 authors of this molecule.
Yeah.
You probably interested in how we came to this molecule, yes?
Very much so. I'd love to hear the history.
History is so. You certainly know about piracetam, yes?
Yes.
Piracetam was invented by one scientist who worked in UCB, in Belgium, in UCB company. And it was his invention. He got a substance which is able to improve memory disturbed by, for example, electroconvulsion or hypoxia. And so he proposed it to clinics. And up to now, some people don't like this molecule, and even, especially in America, they are very negative to this substance. Why? The point is that it has a lot of disadvantages. It means that it works only in very high doses. Now it is doses about 12 grams per day. It is huge doses. And in some people, it doesn't work a lot. So, I am working in the Institute of Pharmacology. That is very old traditional institute. As to personally me, I am working there more than 50 years. You can imagine how old I am. I am 82 years old. Very, very, very active person. I am a lot of fellowship and a lot of students and so on. But let's come to the beginning, to the history of Noopept.
Yeah.
We have in our institute, we have a rather big chemical department. And our chemical decided to do something with piracetam to improve it, because his disadvantage is very low activity. So there, all over the world, there are many chemists who try to improve piracetam, looking around this molecule. But our chemists, they use another way. They move to so-called peptide. Peptide is a chain of amino acids. And also they have positive feature because they are rather active, but because they are close to the body, they are not toxic. That is positive. But they have also negative feature, because they are not stable. They have very low biological stability because of enzyme activity. So, only exception is it concerns long peptides, for example, 10 and 100 amino acids. But if you take 2 amino acids only, it's so-called dipeptides, it is another situation, because they are rather stable, they penetrate good in the brain, so it is very good. But they are 20 amino acids. As you know, it is difficult to choose what kind of amino acids you should take. So our chemists, they are very, very clever, and they compared the structure of piracetam, and they took 2 amino acids, proline and glycine, and combined them in the way to get a molecule which is more close to piracetam. So we got dipeptide analog of piracetam. And it appears that it works very good in experiments. And doses which are 1,000 less than piracetam. For example, piracetam work in doses 200 milligram. It means 2 grams per kilo, and our substance work in 1 milligram per kilo. You can understand what is the quantitative difference. And also, there is a qualitative difference, because our substance works in better way, in wider spectrum of pathology. I am experiment pharmacologist, so we use a battery of tests which imitates the clinical situation. For example, we can have a model of brain trauma or ischemia or aging or prenatal damages, so different kind of damages. And so in all these models, our substance works very well. And it is not toxic. We perform, our toxicologists, they perform the experiments with two kinds of animals, rats and rabbits, and different level of doses, and they show that the substance is not toxic because it is close to endogenous amino acids. So it was very beginning, and we started with this substance in 1995. That is the history.
With such low toxicology, are there any downsides that people should be aware of?
Not yet. It is in practice for a long time. There is really no side effect except of one. The people during the first clinical trial, the people have to write this information list. I don't know how to say. They agreed to be involved in this examination. It was a clinical trial, the second step of clinical trial, and it is rather nervous for me. It gives anxiety for people to write this paper. So many people who has hypertonia, they demonstrate a little bit higher blood pressure after Noopept, but it was we guess it was psychologically. It is very important problem of clinical trials at all, not only in our case.
One of the things I read was that not only does it have neurological benefits, but it can be an inhibitor for diabetes.
Yes, I will tell you. That the point is that now it is clear that brain damages of different origin have the same mechanism of damages. You can understand that neurochemical mechanisms such as excessive formation of free oxygen on glutamic acid and other excitatory amino acids, and excessive accumulation of calcium or pro-inflammatory cytokines. And all these mechanisms are involved in any kinds of brain damages. So it means that, for example, Piracetam, it is a weak substance, but it works in different kind of brain pathology. You understand? It means that the substance who help to recover after stroke, the same substance can help to recover after brain trauma. Do you understand? And after pronounced convulsions in epileptic patients. So the mechanism of neuroprotection is really universal because the mechanism of damage is very similar. You understand? Except of, for example, Alzheimer, where all this mechanism also work, but it is another additional component such a beta amyloid. So it is another mechanism. But there are several common mechanisms in different kinds of brain pathology. So that is the reason why many neuroprotective substances are effective in different wide spectrum of brain pathologies. In diabetes, the beta cells of pancreas are damages, and so insulin is not produced. And from that is the first point. The second point is that ontogenic origin of beta cells and is very similar to that of neurons, and their neurochemical features also are rather similar. So it came to my mind that I can use neuroprotective molecule I can try to treat diabetes. It is only my experimental data, no clinics yet, and I don't know when I have possibility to try in clinics because it is rather expensive and so on. But now we have rather good battery of tests with diabetic model, and not only Noopept is working, but several other neuroprotective substances appear to be effective. So now we are in process, but you saw probably our publications.
Very interesting. Are the amounts of the neuroprotective substances that are effective for protection of the brain similar in scale to the amounts that are effective against diabetes?
I don't know because nobody started. It is just the beginning. You know, there is one lady. Her name is Susan de Lamont. He proposed such idea that Alzheimer's disease can be considered as diabetes of the brain.
One thing that I read about Noopept that was surprising, but in a good way, is that you don't build up a tolerance to it the way that you do with many chemicals, but that it's something that can sustain its usefulness within your body.
Tolerance. No, there is no tolerance. No tolerance. Because, you know, we advise the people use, for example, 3 months use and then take an interval and, for example, 3 times per year as a prophylaxis. Not the therapy, but also by prophylaxis.
How much would be a normal amount for an adult person to take per day?
3 tablets. Each tablet contains 10 milligrams.
It's metabolized pretty quickly within the body then if you're taking it 3 times per day.
Yes, but you know, it's a very important point because all peptides are metabolized very quickly.
What further studies are you working on now? I mean, you sound like such a vital and active person. What is it you would like to see happen next with your invention?
Yeah, I don't know, but I have to tell you that I am taking Noopept for many years, but I am not sure. In spite of the fact that I am author, I am not sure that is the main reason. I guess the main reason is that I am very active. I am very active mentally, and also I have a lot of interest. Well, just I work at the institute, then I come back. I have a very small dinner and very small sleep. For example, half hour, and then I'm again near computer. That is my secret because, you know, unfortunately, I'm a video. I lost my husband when I was 35, and he was also very young. He was a professor of reanimatology, and he got.
Oh wow!
Yeah, he had a heart attack, and he passed away, and so it was my job is my hobby. Unfortunately, it is not very good, but that is a fact. That is a fact.
Smart Drug Smarts.
So thank you so very, very much to Dr. Ostrovskaya for joining us for the podcast. Fantastic to hear about what I think is obviously truly her life's work and a source of great pride and ongoing interest to her. So super awesome to hear about somebody who is up there in her years, but still very, very active and engaged in what she's doing. I think obviously a role model for those of us who are looking to keep our brains super engaged throughout our lives. And now, turning away from Noopept to the ruthless listener retention gimmick.
Smart Drug Smarts. Ruthless listener retention gimmick.
Okay, so I think we've talked about coffee naps on Smart Drug Smarts before, but this is such an awesome thing that I wanted to go back into it again because there's a really good article on Vox.com specifically about coffee naps and how to use them to your advantage and, in fact, why they work. So, quick recap, what is a coffee nap? A coffee nap is essentially drinking a big glass of coffee, then immediately going to sleep, waiting for about 20 minutes while you sleep, then waking up and springing into action. Well, you can do whatever you want once you wake up. But the idea is that a coffee nap, as far as its resuscitative powers for your brain, is more powerful than a nap, more powerful than coffee, and in fact, more powerful even than the additive effects of coffee plus a nap. which seems a little weird. And of course, caffeine has a bad reputation for interfering with your sleep, which is generally true. But here's what's going on and why a coffee nap is as effective as science backs it up to be. So at the risk of radically oversimplifying, we get tired because our brain builds up something called adenosine, or at least the buildup of adenosine is one of the triggers for our brains that we are tired and in fact we should take a nap. So our brain has these things called adenosine receptors. Adenosine is a neurotransmitter, and during the course of our waking hours, adenosine builds up and gets captured in these receptors within our brain, and when we reach some critical threshold of adenosine receptors being filled up with adenosine, we get real tired and either go to sleep or really wish that we could be asleep. Now, what makes caffeine effective at prolonging our wakefulness is that caffeine is chemically shaped very similarly to adenosine, and so it can kind of fit into these adenosine receptors and kind of plug them up and keep adenosine from getting in there, so our traditional mechanism of knowing when we're tired gets kind of gummed up. So you drink a cup of coffee or some other caffeine-containing something or another, you get the caffeine in your body, caffeine crosses the blood-brain barrier, goes into your brain, plugs up the adenosine receptors, and you stay awake longer than you otherwise would have. And so the other part of this process is when you sleep, your brain kind of does a clean sweep and knocks the adenosine out of the adenosine receptors. You're not tired anymore, and that's why you feel rejuvenated when you wake up. So if you think about drinking a cup of coffee or something like that, when you're already kind of partway through this getting sleepy cycle, you've already got some of your adenosine receptors filled up with adenosine, then there's not quite as many open spots for the caffeine to fill up. But if you do a coffee nap, you kind of have this double whammy effect going for you. While you're napping, your adenosine is getting released from your brain's adenosine receptors, and it takes about 20 minutes normally for caffeine that you ingest to actually hit your bloodstream and thus wind up in your brain. So just about the time you're waking up from your nap with your adenosine receptors at least somewhat cleared out, you've got this burst of caffeine in your system which can plug up all those empty spots. And thus, voila, the magic of the coffee nap. I just took a coffee nap earlier today, and I feel marvelous, I might add.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
Okay, you heard it. That is the episode number 46, Cruising in for a Landing. Thank you very much for staying with us. You're once again invited, by the way, for the iPhone users out there, to download the new Axon app that we've recently published. By the time this episode comes out, version 1.1 should be in the store, and we're coding on 1.2 now. 1.2 is going to have some pretty neat little goodies in it. 1.1 was just kind of a couple bug fixes. But yeah, get your app while the getting's good. I will be back at you next week, same time, same podcast, and with the same unflagging commitment to fine-tuning the performance of your own brain. Have a great week, and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.